So when I was looking at all the videos last night and trying to figure out what the issue was, it seems to be just being my new computer that all the videos that I made over spring break, anytime I went over to the side, it muffled my voice for some reason and made it very difficult to hear. I don't want it to become difficult for you to learn, so I'm going to re-record all of the different videos that I created. So 13.6 is our measures of center, and then we're going to talk about variability, how many different options there are when it comes to our answers. So in our measures of center, we're talking about mean, median, and mode. Variability then usually talks about those box plots, where we create our lowest number, our highest number, and then we do our median, our lower quartile, and upper quartile, and we box them in. And we see which of those ranges have the majority of our data information in them. So when I look at how this information is being applied, so yesterday's lesson, it was kind of a difficult lesson, and I will never take that away from you. We're not used to thinking about all the information that we're doing and solving for when it comes to mathematics. And that's what 13.5 was all about, is beginning to think about how we can apply this information. It's really an introduction to what we're going to be doing over the next couple of lessons. And the next couple of lessons are more fine-tuned and focused in on what 13.5 was trying to get you to do. So hopefully 13.5 wasn't too difficult for you, but please understand also, I knew 13.5 was going to be difficult, and I just give you a completion grade if you did the assignment. So if I have an assignment for you, you got 100% that's going to go in my grade book. If you didn't do it, well, then that was a poor choice, and you won't get as many points as you could have. 13.6, though, I'm going to grade as a full assignment because it is easier to understand because it becomes more focused on what we're trying to do. We do the work, we do the data, or we take the work that's already been done for us and we think about what it's trying to tell us. So when I look at this information, I can see that we're talking about sports teams and the information that's been gathered because that's the title of my data chart. I can see we're talking about specifically baseball and basketball because those are the two different teams. And even more specifically, we're talking about the heights of the players because it says baseball team heights and basketball team heights. So then we have two measurements that we're going to be examining and thinking about. We have our median, which is a middle person in the group. For the baseball team was 70 inches. So we had people that were shorter than 70 inches. We had people that were taller than 70 inches. We may have had 1 or 2, 3, 4, 5 people that were 70 inches. But the median measurement for their heights was 70 inches, where the basketball team was was 78. And we would expect basketball players to be taller. Not that there aren't tall basketball players. Okay, so Randy Johnson used to be a pitcher for the National Basketball Association, but he was one of the tallest pitchers that we've ever had that played professional baseball. Basketball players are in general taller individuals, though. And we can see with those teams, that median person is 78 inches. We can also tell that she did a box plot, and we can tell that because it talks about the interquartile range. So once again, we have the smallest number, highest number, marked on our line. We also then have our median, followed by our lower quartile and our upper quartile. The range overall was from highest to lowest, subtracting them. The interquartile range is taking the upper quartile and the lower quartile and subtracting those. So what's the difference in the ends of the boxes compared to the overall information of the data that's collected? Knowing what that graph is telling us is important to be able to answer these questions that were being asked. So now we're going to get into the scenario that they give us. Julia is collecting data on her favorite sports teams for a report. The table shows the median and the interquartile range of the heights of the players on her favorite baseball and basketball teams. How do the heights of the two teams compare? So now, I don't know how to change the color on this to make it clearer. When I make it brighter on my screen, it whites it out. When I make it any darker than this on my screen, then you can't see it at all because it blacks it out. So if you're following along in your book, then you'll be able to tell where I am, but hopefully you can see it okay from your computer. So this says we're going to focus in on the median. So we're talking about this first column of data. The median of the blank player's heights is blank inches greater than. So that's how we know which ones go in which order. because we're looking for the number that's greater than the median of some other group of players. So the largest number of the two is the 78. So I know it's going to be the one that we're talking about. So I have the median key point information that we're talking about. So I have to go in that first column, and I have to look for the one that's greater than the other median. So that tells me I'm going to use those first two numbers in that first column. So I'm going to focus in on using the 78. I know that the 78, if I find the difference between them, 78 minus 70 is 8. So I know that the basketball players' heights is how many inches greater? 8 inches greater than the median of the baseball players' heights. When I go to the interquartile range, which is the second grouping of information then, it says the interquartile range of the baseball team is blank the interquartile range of the basketball team. So I have to go to my second group of data, my second column, and I see 6 to 4. So that is kind of flipped when it comes to comparisons of which one's greater and which one's smaller. So the baseball team is now larger than or greater than the interquartile range of the basketball team. So the heights of the baseball players vary what? They vary more than, because there's a bigger range in my interquartile range, they vary more than the heights of the basketball team. So the players on the blank team are typically taller. Who has typically taller players? Well, we see in the median, the basketball players. Then the players on the baseball team, because that's what we're comparing, basketball to baseball. And the heights of the blank team vary more. Who had a larger interquartile range, whose box on a box plot was going to be wider and more spread out. The baseball team has a bigger variance. So they vary more than those of the basketball team. So a couple people had come back yesterday and really struggled with the question. I introduced and gave the answer on the video in 13.5. And you were supposed to write it down in your book, and then you had a question on the assignment. And I went through that question on the video because I knew it was on your homework assignment. What does it tell me if I'm doing a box plot and the interquartile range is small, or if it's big? And what that's telling you is on the interquartile range, from the upper quartile down to the lower quartile, if it's close together, then there's not a huge difference between the data that has been collected. There's not a huge difference. There's only a 4-inch difference between the majority of the data for the heights of the basketball team. However, the baseball team is more spread out. So that means the players, there's a bigger variety of heights when it comes to the players on the baseball team, because there's 6-inch difference between the majority of that team. Now that would not include your outliers if they're larger or smaller, and I understand that. That's all those boxes are telling you. If it's close together, then the majority of my information is more compact in a smaller range. If my box is more spread out, then my data information is going to be wide variety. It's going to have a greater variance in all the information and the data that I've collected. Let's apply that to this then. Julia randomly picks one player from the basketball team and one player from the baseball team. Given the data, this data that we just did, given the data in the table, can you say that the basketball player will definitely be taller than the best baseball player, and explain your answer? Can you definitely say, since the median is 78 for the basketball players and only 70 for the baseball players, that if I randomly pick one of the players from each of the teams, that the basketball player is going to be taller? No, that doesn't make any sense, because we could have a really, really tall baseball player out there. We could have a 7-foot baseball player playing center, and we don't know. So no, I can't say that for sure that that's a definite answer. Yes, a basketball player has to be taller than a baseball player. It's not a good way to use the data that we collect. The median height of the basketball players is greater than that of the baseball players, but that does not mean that they are all taller than each of them. So please have that written down in your book so you understand what we're doing here on this lesson. No, it does not mean that one's taller. The median height of the basketball players is greater than that of the baseball players, but that does not mean that they are all taller than each of them. So pause the video, make sure you get this written down before you go on to the next slide. On this one then, we're going to look at two different individuals who are selling t-shirts as a fundraiser to make money for their club. So I have Kamira and Joey. They sold t-shirts during their lunch to raise money for a charity. The table shows the number of t-shirts that each student sold each day for 2 straight weeks. Find the mean and the range of each data set and use these measures to compare the data. Well, first, one of the things that I always like to do is figure out, do I have the same number of days that we've collected information? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, so I can compare these overall. Now, I've seen questions where they try to trick you and they give you a data set up here and a data set up there, and you find out that the top data set has 2 extra days added to it. That's not a true comparison. The only way that could be a comparison is if they just simply say, well, on average, who would sell the most? So we really have to make sure that we understand all the data that's been given to us. So the first thing I want to do is I want to find the mean of both of these. Now, if I'm finding the median and I'm finding the mode also, I would want to put them in order from least to greatest. I always strive to put them in order from least to greatest. Some of you on 13.5 came back to me and you were really struggling with the median because you weren't putting your information in the order from least to greatest. Several of you did not do well on your mid-chapter checkpoint because at the bottom on the front page, when it talked about find the means and find the interquartile range, which had to have the medians and stuff, you didn't have any of the information in order from least to greatest. And I went over all 4 of those first lessons and said the number one thing that we have to start with is putting them in order from least to greatest. So if we just do that when I'm doing these type of questions, that eliminates a lot of problems and misunderstandings that we have from the beginning. When I have them in order from least to greatest for Kamira, and I know I had 10 days that we sold during our lunch times, then I'm going to find my total at the top because the mean means the total divided by how many are there. So I'm going to take and add them all together and I get 30. And then I know I'm going to have 10 days, so 30 divided by 10 is going to give me an answer of 3. Handy dandy calculator, type it in, 30 divided by 10 gives me 3. I know the mean, the average number that you sold each day would be 3. Well, what about Joey? Well, if Kamira sold 3, let's see what Joey did. Joey had a really big day out here, right? What would we call that with a 13 when everything else was 4 or less? Hopefully the word outlier popped into your head, something that you need to know. So when I add all of those numerators together, I end up with a total of 30. This is the exact same problem as down here. Joey also sold 30 over 10 days. His mean is also 3. Now, one of the things we have to do, and the book throws this in there to remind you, something that I mentioned in the first several lessons. So I put a star by it so that we would point it out in our book. It says to make sure that you include zeros when you count the total number of data values. I have had a couple of you in the first couple of lessons when we were doing mean, that when it was a 0, you just dropped it off. So you would have divided that by 8 and got some kind of wonky decimal number. So we don't need to worry about that. We just need to include it. There were just 2 days that he just didn't sell them. Maybe he was out sick, had an ortho appointment or something, wasn't there for lunch. I don't know. But he didn't sell any on those 2 days. That's going to affect the next points of center that we look at, but it doesn't affect the mean. On average, he still sold 3 t-shirts a day. When we look at this information then, on our range, that's where some changes begin to happen. So in our range, once again, range, if I go to a golf tee, I hit my golf ball, let's say I'm really bad at it and it only goes 12 feet. How do I know it went 12 feet? Well, I'm standing at 0 and it landed 12 feet away. And so I know it went 12 feet because I take 12 minus 0. When I talk about range, when it comes to data, it's taking the highest number and subtracting the lowest number from it. One of the reasons why they have to be in order from least to greatest. It's not the first number in the list and the last number in the list, because they're going to mix them up, and that's going to get you the wrong answer. So on my range, when it came to Chimera, I put this image up here because this is what we had. We had 5 and we have 1 that we have to subtract. So 5 minus 1 is going to give me a range of only 4. When I go to Joey's, Joey had that outlier of 13, and he had a couple lazy days or a couple days where he couldn't sell t-shirts, where he didn't sell any at all. So when I take my 13 minus 0, his range is 13, a much bigger variance or variability in his range. Well, let's look at what the next set asks and see what kind of comparisons we can make here. The means of Joey's sales is what compared to the mean of Chimera's sales? Well, they were the same. They both sold a mean or an average of 3 t-shirts per day. But the range of Joey's sales is what? It's much greater, but it's greater than the range of Chimera's sales. So the typical number, and this is our thinking pattern that we should be going through when we're going through our data, the typical number of shirts that Joey sold each day was what? Well, the typical number of shirts that he sold was the same as Chimera. However, since the range of Joey's data was greater, it had that range of 13 compared to her range of 4, the number of shirts that Joey sold varied more from day to day than the number of shirts that Chimera sold. So when I look at my range being so drastically different, we could talk about an interquartile range compared to a regular range, because we have one that's really spread out and one that's more compact. Okay? So when I look at the 2 different ranges, she was pretty consistent. About 3, about 3, about 3, about 3, about 3, all the way through selling the t-shirts. He went from, well, anywhere from 0 to 13 sold in one day. He really hustled on that one day to get that outlier. But they ended up with making the same amount of money for their club. All right, so when we go to the second scenario that we have points scored, looking at our data set, player 1, player 2. I once again have a mean and an interquartile range. Well, what are we talking about? So when we go to the question here, we have Zoe collected data on the number of points that her favorite basketball players scored in several games. Use the information in the table to compare the data. So we're going to assume that they all played the same number of games. We don't know that. How many games is that? We don't know that. What kind of extra math can I do? Can I find the mode of this question? Can't find a mode. Can I find the range of this information? Can't find the range. So this is focusing in on just using the data that we're given and how we can interpret it and apply it. So that's where the thinking process comes in. So when I look at it, the mean of players 1's points is blank the mean of players 2 points. So we're looking at a comparison between greater than, less than, or equal to. So the means, when I look at it, player 1 is 24 and player 2 is 33. Well, the mean of player 1 is less than the mean of player 2. All right, we can get that from that data. Well, what about comparing the interquartile range? The interquartile range of player 1's points is blank the interquartile range of players 2 points. Well, I go to the second column then, and I have a comparison between 8 and 16. So player 1's is less than the interquartile range of player 2. So they score less on average, but that interquartile range between the variance of how much they score is much closer together. So player 2 typically scores more points than player 1, but player 2's scores typically vary more than player 1's scores. So that would come into play if you are a coach and you want to make sure that you win the game. Are you going to play the player who, on average scores 33 points, but one day it could have been they scored 50 and another day they scored 4? Or do you want that person whose interquartile range is closer together, and so they may score 26, they may score 28, they may score only 20? The closer that interquartile range is, the more reliable the information is because it's more compacted when it comes to this type of scenario. A player, you want to be the one that has more consistency. You may not win by a whole bunch, however, you have a greater chance of playing player one because they're more reliable when it comes to scoring points. What about the second one then? The second one gives us lists of data and information, and it's talking about puppy weight in a pound, or actually in 2 pounds, shelter A and shelter B. It says Mark collected data on the weights of puppies at 2 animal shelters. Find the median and the range of each data set and use these measures to compare the data. So I have to find what? The median and the range. So I have to put those in order from least to greatest. So when I look at shelter A, I put them in order, and I should have on my paper in my book 5, 7, 7, 7, 10, 12, 15. And then I just put them on top and on bottom so I could keep them in order. So shelter B you would put underneath, or you can write them in a different spot, it's fine. Putting them in order from least to greatest also would be 4, 5, 5, 11, 11, 13, 15. And then when I make sure I had 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, I got all those. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. I've got all those. So I know I have all my information written down. Now I have to find my median. So once again, my median, I cross off the same amount from beginning to end. If I have a middle number because it's an odd grouping of data, then I know that's my median. If there were 2 of them, let's say there were 8 puppies that were weighed, I would have to add the 2 together and divide by 2. Or if it was the same number, I would just keep it. So I know my median for A, there it is 7. And what about my median for B? So I cross them off, I get to my middle, my median for B is 11. So I know that I have my medians of 7 to 11. Well, my ranges, once again, is measuring from the highest number down to the lowest number. So I take my highest one and I do my subtraction. I have 15 and 5. 15 minus 5 gives me a range of 10. And on the second one, I have 15 and 4. 15 minus 4 gives me a range of 11. So then when we compare them, we look at what we're talking about. Use the measures to compare the data. Well, shelter A, if I just talk about my medians, shelter A, my median is 7 pounds, where shelter B is 11 pounds. Well, what about the range difference? Well, there's only a 1 pound difference in range, and that's really not a big difference. My range was 10 pounds for shelter A and 11 pounds for shelter B. So when I compare them, my focus point is really going to be on the median. So when I finish up, then I wrote the range is similar, but the typical weight of B is greater than the weight of A. So make sure we have this written down. First, I explain my data. Shelter A has a median of 7 pounds and a range of 10. Shelter B has a median of 11 pounds and a range of 11. Then my explanation and my comparison is the medians are very similar, but the typical weight, that median weight of B is greater than the weight of A. So when I look at the shelters, we would, in our minds, say, well, the ones at B are going to be healthier because they have larger puppies. That would probably be the better place to go when I wanted to go and pick out a new puppy. Make sure you have that written down, please, in your book. Then we're going to look at this data set, and this compares a couple of different things and different ways of looking at them. Now, once again, there can be times where we say which ones are closest to each other. They don't have to be the exact same mean. They don't have to be the exact same median. They wouldn't have to be the exact same mode unless it says which ones have the same. Okay, so this question leaves some leeway with that data information that we're talking about. So we're talking about practicing for band. We're talking about 4 different students. We have Sally, Matthew, Tim, and Jennifer. We have a mean of the amount of time that they practice per week, because it says hours per week. And then we have a range of how many hours per week they practice. And so we have three different questions that we're going to go through and figure out what that data is telling us. So once again, this lesson is about thinking about what it's telling us and working through it. Which two students typically practice the same amount each week with about the same variance or variation in practice times? Which two students typically practice the same amount? So that is my mean. And variation is about the same in my practice times. So when I look at it, I have 3 students that practice the same amount. 5, 5, and 5. The range, the variation, is 2, 12, and 3. So that 12 really doesn't fit in very well with this answer. So when I look at it, I know that they both practice 5 hours. Sally would practice 2 on average, and Jennifer 3 on average with their range. So they practice pretty close to the same amount of time every day. So those 2 would be my answer for question 3. Question 4 changes the type of question we have then. Which two students, typically practice the same number of hours, but had very different variations in their practice times. So look at the chart. Which ones practice the same amount, and their variation, their range, was very different from one another. Now, I'm going to tell you that some of you may have one answer and some of you may have a different answer with pairings of students, but you would both be correct. Because there's actually 2 answers to this question. When I look at what the setup is, I can look at Sally and Tim. So Sally practiced 5, Tim practiced 5, but the variation, the range was very different. The range for Sally is only 2, where Tim's is 12. So you could say Sally and Tim, but you may have noticed that Tim and Jennifer also practice the same amount of time. And the variance between 12 and 3 is also a very big difference. So you could have said Tim and Jennifer. There's 2 answers for this question. You only need to have 1 written down in your book. Now, on your homework assignment, if you have a question like that, I will only expect you to have 1, not all of the combination possibilities that there are. Finally, on 5 then, which 2 students had the same variation in practice time, but typically practice a different number of hours per week? So now I'm looking at my range, which is the same, and I'm looking for then the mean to be different. And the range that is the same are the 12s, but the mean, the average amount, is different from one another. So they had a range of 12 hours. So one day they may have practiced a whole bunch, and one day they didn't practice maybe only 1 hour. But their mean overall is very different. Matthew practiced an average of 9 hours per week, where Tim only practiced an average of 5 hours per week. So those 2 would go together when it comes to that answer for question 5. That takes us to our assignment. So now we only have 2, 3, and 4 on our assignment for tonight, and then only 5 on the back. So you have 8 questions to work on for your homework assignment. Once again, 1 and 2 are going to be like this assignment that we just went over, to where 3, 4, and 5 are going to be that spiral looping review of things that we've already talked about. So as you're working on it, if you have any questions, please come and ask. Those of you that did not do well on your mid-chapter checkpoint, you have until the end of school on Friday to make corrections, ask me for help, use your book, use the previous videos, get a better grade and earn some points back, because there are some of you that really need some of those points to be earned back.